Okay, the table method is where they're giving you values for x, values for y, when you've got two different functions and you have their derivative functions, and you use the given equation. So this says we need to find, given h of x, we need to find the derivative of h when the x value is 2. So first thing we're going to do is we're going to highlight, this is what I would do, or somehow if you don't have a highlighter and you don't want to do that, just kind of say, okay, we're focused here. Well, when you're adding functions, the derivative is just so what you're going to do is say, to find the derivative of h, you're going to take the derivative of f and you're going to add the derivative of g. And then instead of x, you're going to plug in. So we probably could have skipped that step. When you're doing this, you might want to just do the step that I just did. So the derivative of h, so we look at f prime when x is 2, and we look at g prime when x is 2. So we're just going to say the derivative of h is negative 3/2 plus 1/2. When you add those together, you get negative 2/2, which is negative 1. So remember, derivative means instantaneous velocity, right? So if the graph was doing something like this, and so the slope of that tangent line might be down 1 over 1. Remember, every time you think of derivative, think of instantaneous velocity or slope of the tangent line. So we're going to do the same thing. We're going to do subtract. Again, we're at the x value of 2, and what we care about is f prime and g prime, but we've got to subtract. So h prime, when the x value is 2, is f prime of 2, subtract g prime of 2, the x value is 2. So f prime at 2 is negative 1, subtract g prime is 0, just like that. Okay, gets a little bit more complex when you've got a product rule. Remember, the product rule would say f times g prime plus g times f prime. And then we're at the value of 1. So the derivative of h when x is 1 is f of 1 times the derivative of g of 1 plus g of 1 times the derivative of f of 1. If you organize the information this way according to whatever the derivative rules are, and you plug the x value in, it's going to make it way easier. So I'm going to do this, and then I'm going to maybe circle the derivative ones. So now f of x is 2 times g prime is 2 plus g is 1 times f prime is 2. 2 times 2 is 4. 1 times 2 is 2. When you add those together, you get 6. So the instant velocity when x is 1, so maybe you have a graph that's looking like this, and maybe at 1, I don't know, it'd be steeper than that, but, well, depending on the graph. But anyway, all right, now we've got a quotient rule. Remember the quotient rule. So h prime of 2 would be g of 2 times f prime of 2, subtract f of 2 times g prime of 2 all over g squared. So x value is 2, so it's this column right here. And here are your derivative values. Okay, so g is 3. F prime is, here, I'll put them in parentheses, -1/2 minus f, which is 1, and g prime is +3/2, and all of that is over g, which is 3 squared. So we've got -3/2 subtract 3/2. Well, that's going to be -6/2, which is -3 all over 9. And then 9 can be simplified. So the instantaneous velocity, or h prime of 2, is -1/3. Okay, now we've got a chain rule. So we need to know, okay, we're going to go ahead and back this up a little bit, because I'm going to go ahead and say that we're going to go ahead and use this information right here. All right, so h prime of 4 in this table method. So even though normally it would be 2 times all of that, what this table is saying is that, yeah, but we know what that is. We know that that's going to simplify. So we have -1 with the g inside times the derivative of g. So in this case, it would be that. And I think that is this for the table method. This one in particular is a little bit tricky, but if you organize the information, it's not too bad.